Let us start our class today. We, are, we have started the steam generator control system. Now, as I've discussed, the steam generator is not a single unit or a single machineries or single integral part machineries itself. It is required by turbine at design the steam flow. The object is control is to provide the steam flow required for turbine at design temperature and pressure. Just 1 second. Now, the objective of steam generator control is to provide the steam flow required by turbine at design temperature and pressure itself. Turbine for a particular output of torque or a particular output of the generating capacity requires a certain minimum and a certain range of temperature and pressure itself for the steam, which is the input of it. Here, turbine is giving us the output, the torque as well as the or electricity as well as, but it is giving receiving steam at a desired design temperature and pressure as an input for it, which will run the turbine. Now, the variables they are that are to be controlled mostly are like this: say fuel firing rate, air flow, gas flow distribution, feed water flow, and turbine valve setting. What is this? What are the variables like this? First of all, air fuel firing rate. Air is being used to burn the fuel, and how much air is required to burn a known amount of fuel is an important factor. It also varies from fuel to fuel, even from one grade of coal to another grade of coal, etc. In steam generator, we are rapidly but vastly on generally using the fuel as coal as the fuel itself. But all the coals don't have the equal ignition rate. So we have to control a specific fuel air fuel ratio to make a required rate of firing. Say you can burn a certain tons of fuel after within a certain time, and how much cubic foot of air is required to make it possible, you have to know, and you control the flow of the air accordingly. It may vary from fuel to fuel, it may vary from coal to coal, but you have your requirement of electricity will not vary from coal to coal. It will have to provide a definite electricity for that. So you have to control the air, and you don't have much control over the fuel because it is maybe this type of fuel is only available with you. You cannot change it, and this is the amount of fuel you can burn in this burning capacity of a furnace of this so many tonnage of fluid is required. You cannot change it much, so you have to change the rate of airflow. So, what is the firing rate in a fuel? It's supposed to be given by the the control system itself. How much part in time firing, how much fuel is being burned is you have to control accordingly. You have to maintain your burning temperature, your controller vibra operate your controller accordingly. Next is the airflow. Just I have told you that airflow is the important part which you can control easily than controlling the fuel and fuel burning rate in a case. So you have to control it, and you have to know how much air is required for this type of fuel to produce this amount of heat, and this should be the firing rate of the fuel itself. Next is the gas flow distribution itself. The what is why gas flow distribution is a fuel is fired and a smoke is generated. That is we are calling gas, because smoke is a definite specific content of different type of toxic fluids or toxic gases, not only a black spume. There are a lot of important and toxic gases which you should get certain other treatment. You can throw it outside. And but this that's a different issue. The gas flow distribution is how much gas you are producing is also an important factor for your control. Means this gas will carry the heat of the uh, burning fuels or coals to your risers tubes or your preheaters, air preheaters, reheaters, etc. everywhere. These gas are being conveyed, and this gas acts maybe convected, heated, being transferred by convection from the gas itself, not directly from the fuel. I mean, from the flame of the fuel itself. It may so happen it creates a huge energy as it creates a huge heat energy which will heat your respective parts like riser tubes, like your superheater tubes, reheater tubes, and primary, secondary, pendant superheater, everything by radiation itself. But that is being created by the gas flow, that huge amount of energy this should be released from the flame of the burning of the fuel will be carried to respective position, and if not carried, this heat is being transferred by radiation from the gas itself. Next is the feed water. Feed water flow, we are just boiling by means of burning the fluid, we are boiling the water in a, say, boiler drum, ground downcomer, a riser system, or maybe this system is totally natural circulation is there, but you can using a power driven motor which will give you the required circulation like this. But everywhere how much feed water is being used here and how much are wasted or this converted into vapor and not cannot be utilized, cannot be recollected after the turbine operation, and how much you have to give again and again a new fed water which you have to know, and that is you are supposed to be controlled by your controller itself. Last but not the least, the turbine valve setting. Turbine is run by the injection of the steam at a definite high kinetic energy. The heat energy, huge heat energy of the steam, superheated steam will be converted by running through the nozzle into the kinetic energy, which will inject over the turbine flow itself, and it will get the required rotation for say 6 or few thousand of RPM, etc. as per your design requirement, design pressure, design requirement of your system itself. So, as a whole, the uh, turbine valve setting is possibly the most important part, which is controlling your total generation of energy and electricity by giving you the secondary pressure, giving you the design pressure with which you will push the steam inside the valve, and thus creating high kinetic energy with which you are high design temperature with which this high kinetic energy which will be converted into this valve itself to net in form of kinetic energy that will move the turbine setting itself. So the key measurement that describe the plant performance are steam flow rate, feed water flow rate, and steam drum load and electrical power output. So what is the measurement which you are supposed to do? That is steam flow rate, how much steam you are flowing in over the system after generation, after it's converted from water to steam. What is the specific flow rate, how much say cubic meter per second, so many parts per second, etc. Feed water flow rate, which is required to balance. Actually, the same water is being circulated throughout the system again and again, but you cannot never recover the same water. Recover the 100% water and convert it to again to the stream. You have to feed certain amount of water itself. So this flow rate throughout the system is also important to know because you have to know how much you have to add to the feed water itself. Next, the stream drum load. Stream drum or drum of this is one of the possibly the heart of this type of machines, where which is collecting this feed water. It is being sent through downcomer to the riser, where it is converted to the partly to the maximum to the steam and sent to the drum again, where the heavy water falls in the down and steam thus generated in the riser goes up to the superheater itself. And whole water is fully saturated with the steam as per the design or running pressure of the drum itself. So that total water is saturated means maximum stream with this water under this pressure can be absorbed with this given inside the water is some saturated in the water itself. And again, when you are heating, it has no other alternative but to release this water will have no other alternative but to convert it into steam and goes back to the drum and report it again. Thus, you have to feed a certain amount of water regular interval through the feed water rating itself. And electrical power output, how much power you're supposed to generate per hour, or how much megawatt, how much watt megawatt per hour and per second. This is the which is the minimum requirement of output, and what should be the maximum requirement with which you can produce. And before that, you have to make control everything so that the power output you can reducing. The control system must act on the measurement of these plant parameters so as to maintain the plant property at the desired condition itself. So based on five which factor, maximum, what is this? Maximum important the steam turbine setting, mostly steam turbine setting, that the plant steam flow rate, with steam action rate and electrical power output. The variable factor that control the steam rate is the turbine valve setting. That is the most important matter to control because that is controlling your so many things you are doing, but it will be only through the when you go through the set of valves and how much quantity you are producing is the most important part to produce torque. So the control here is the ultimate requirement itself. So all these factors are required to control it, like steam flow, because that will generate heat, the water feed water flow that will replace the wasted water, and steam flow rate throughout the system itself. Now, the most modern control instruments employs closed loop control. Means loop control should control a specific output in a small loop because it is comparatively easier to run and control your parameters in a small loop unless you are going to a number of parameters to a bigger loop itself, because your control will be comparatively less then. So in this method, the actual output of the system is measured and compared to some design demand signal set points. So what will be the output? Means what will be the energy of the system and what will be the power output of the turbine is to be compared always to some design, some demand signal, some set points, whether you are doing it or not. Those governors will be set according to it. If it doesn't set, it is setting more, you have to close the moving, you have to close the valves to reduce the pressure. And if it reduces this, you have to increase the steam flow from everything. But that's true on the closed loop, so that more steam, more water burn, I mean the coal burns, more producing more heat. It is more steam is being generated and comes up to the control itself, and that too also a minimum nominal amount of time itself. Now, the difference of between measurement and the demand called the error signal. What you are producing and what you are supposed to produce. That is the difference in the symbol is defined as the error signal itself. It is then used to reduce the difference between the requirement and set point to 0. So this control system should be such that the difference between the set point and this within the measurement and set point, how much you are producing and what is the set point, what is the difference between them, more or less. That is the most important part to know. Proportional control is the simplest type of closed loop control. In its method, the controller output is proportional to the error signal. So what is being control is proportional to error signal. Higher will be the directly proportional. So higher will the controller output, signal will review more. Now error signal will increase. Now what happens? The control signal will be either directly or inversely proportional to the error signal depending on the control action required. This control required should be directly proportional mostly, but it can be inversely proportional also to error the signal to the error signal. So control signal will be is proportional to the error signal. This is the important thing. What is the signal you receive the control, and this signal will be proportional to the error signal, maybe directly or maybe indirectly. Acha. So, or directly or maybe inversely. And in order to, depending on the control section parameter itself. Only a few basic control systems are released, only basic control system to feed water and drum fuel, basic control system to feed water and drum level, steam pressure and steam temperature are discussed under. So what we are discussing here, the feed water, how you will feed water, what will be the drum level, what is the position of the level of saturated water in the drum, and what is the maximum, what is the minimum. The stream pressure, what is the amount of stream, what is the pressure with which the stream is being generated in this system, and steam pressure is just discussed earlier. You have to control these four parameters like this. What is steam pressure? One is steam temperature. What is the water level, drum level, and what is the feed water level. These four factors you are supposed to control in a closed loop. Means they are not integrated parts at the same time. So their functioning also depends on each other's function. But still, if possible, you can locate individually individual items separately and locate the control system as a closed loop that system is itself. Now, what is the feed water and drum level control? The feed water and therefore the steam flow is controlled to meet the load demand by of the turbine, and at the same time mentioned to level the water in the steam turbine within the relative narrow limit. Steam flow, what we are controlling is to meet the load demand by the turbine, at the same time maintain the level of water in the steam turbine drum with a relative narrow limit. Normally, steam flow is controlled to meet the load. First of all, at one number, at the same time we are meet the load, at the same time it is making the level of the water inside in the desired steam without narrowing the limit. Otherwise, normally at the level the drum is acquired maintain half a pool up to the differential plane. So what is going on here? The feed water and steam water is controlled so that what is feed water, flow of feed, what is the steam flow, you have to control as per the load defined by the turbine itself, and at the same time mention to the load of water with the steam drum within relatively narrow system limit. Same time maintain the water of and at the same time maintain the water of level of water in the steam drum within relative narrow limit. Normally, water level in the drum is maintained half to full up to the diameter plane. So, how much drum can allow here? It should be at least half to the half should be filled up with saturated water up to the diameter plane. As per its diameter, half should be filled up, and and same time to maintain the levels of water this half limit, and normally we started with half speed, then high speed consumption by the turbine composed with high pressure should be just 1 second. Now, so what we are doing, as per the load, the demand of the turbine, steam flow is controlled. as per the load design of the turbine. And at the same time, in one way, and at the same time, you have to maintain a level of water in the steam turbine within relatively narrow limit. Just a second. And normally the laboratory drum is maintained at least half fill up to the diameter plane. So if you make a diameter inside the drum which is parallel, or if you imagine a plane as per the diameter which will go to the center line of the center line of the drum, and steam should be at least within this limit itself. Now it should be half fill up of the diameter plane, but high steam concentration of the turbine compared with low pressure. Just a second. 37%. To lower the water level in the drum, the high-speed steam consumption of the turbine compared with low feed water supply. If steam consumption is high and feed water supply is less, the lower drum level will be lower. Drum level can be as high as almost at the top, but it can be lower than the half of the drum itself. A three-element automatic control system, which is of which drum is one element, as in the figure what is shown here. This is the drum, steam drum. This is the steam coming out. It is the water being filled by control valve, and feed water is being fed here. And natural drum water level in the drum itself is the natural, and we are not showing the riser tubes here. Here, what is this? How will you sense it? There is a controller here. It will sense the drum level, feeder flow sensor, and steam flow sensor. So here, this controller will be part like this: say steam flow sensor and feeder flow sensor first. This gives a signal how much steam is feeded and how much feeder water is being supplied. Next, another thing, drum level sensor will be also provided. So what is the demand different of the drum level itself. Next, it goes to the control valve, and from here it directly goes to the system. There is a control valve. Is the amount of reduced, you have to fill up the amount immediately, so that it goes back to the steam drum and again follow the same thing, being saturated with the liquid stream itself. The drum level sensor responds to the error between actual drum level and its set point. There should be a sensor inside the drum level. It will represent the error between the actual drum level and its setting point. So, what will be it will find out the difference between the set point and its level. If it is okay, it will not open the valve. If it is not okay, it will, by sensing, it will open the valve and do the remaining work, so that the water and everything will comes inside and got heated, so that steam content is improved. At the same time, increasing the feed water level and valve is opening the meet the steam flow demand. This author may not be, maybe too slow. This action maybe is too slow. The action may be too slow, and it can be supplemented by sensors for feed waters and steam flow. So just to sense what is the amount of feed water, what is the amount of water present in the drum, and how, so when we have to open the valve, open the cooling valve, control valve, so that it is being fed to the power itself, to the upper part of the drum itself. Now, this action is supposed to be not very fast. It is slow and supplied by some feed water and with steam flow. The difference between these two sensors anticipated partakes in drum level, and sends a signal to the controller to activate the drum in the desired uh, location location typical gauge glass of shown in the figure. So what we are doing, we are just calculating and sensing the change in drum loads and a signal to um, this action too slow, then the action or the food level, and signal to this ground controller is to actuate the valve itself as its temperature is less. To avoid desired technical gauge, the stress class is shown below. Hmm. So what we are doing here, we are sensing the level of the drum. We are sensing the level of the drum, and we are informing if the drum is level is okay, no problem. If it not okay, this we have to increase the feed water level to open the steam flow demand, and this reaction may be too slow, and it is supplemented by sensors for feed water and water stream flow. Now, the difference between the difference between these two sensors anticipated anticipated change in the drum level and sends a signal to the controller to actuate the drum. So the difference between the there are two sensors, feed water sensor and steam flow sensor. The difference should be an anticipated change. So it will send to a signal, feed water is less or feed water is more, steam flow is less, the steam flow may be high, feed water is less. So the difference between this should be a different limit. And if the sensors with anticipated changes the drum level and sends a signal to the controller to actuate the level. They actuate the valve in the desired condition itself. So both way you can act. You can actuate the steam supply valve to the turbine. It is become closer, so the supply is a bit reduced, so that the container in the drum it gets sucked up to the desired limit. All you will feed the air and water, feed water in the itself, so that the to increase the required flow rate. And this controller will calculate or calibrate the steam flow rate, which is given here, given in the turbine blade itself. For continuous monitoring, typical gauge glass is shown here. A continuous monitoring of the water load in drum, the gauge glass or water load indicator is used here. Is one leg of a gauge glass is attached to the water space and the other leg to the steam space of the drum itself. So continuous monitoring system of the water level drum, how you do gauge glass is our water level indicator is used here. Here you have to see through a glass what is the water level, and uh, other leg is the steam space of the drum itself. So somewhere here and somewhere here. So those indicators are there, steam indicators as well as gauge glass unit and steam indicators as well as water space included. It is made of corrosion resistance box panel glass for functioning of vision and mechanical strength. It is made of this steam spinner. It is made of corrosion resistance uh, borosilicon glass. Glass is not a special type, so that you can withstand high temperature at the same time. You can give clear illumination and reality of mesh system and mechanical strength itself. Now, the steam level control sensor responds to the error between And this, yes, corrosion resistant voice certificate for clarity of vision or mechanical strength itself. Let us go to here next stage. Steam pressure control. That is 38. The steam pressure control. The pressure control system, sometimes called, yes,
Sir, no one in the class left.
I know, I know. I am hoping that you will join.
Why?
And I am doing
Why,
my
sir?
work. Yeah. I am hoping
What
that you
out?
will join. I am doing my work. That's all. I will conduct my class.
Yes, sir.
It is your duty to come and join the class, not mine.
Yes, sir. But sir, some issue are there in the LMS. The LMS is not opening that, sir.
Yeah.
Sir, I told you several times about the HOD, but there is no any response. LMS is not work my phone.
But your net,
Yes, sir.
your,
LMS मेरा खुल नहीं रहा है, sir.
your classes strength is over 40, and none of your net is working. It is not an excuse.
Sir,
At least 50% net is not working.
सर
Sorry.
मेरा कहना है ये सर कि मेरा एलएमएस खोल नहीं रहा, सर अटेंडेंस होता नहीं है सर. प्रॉब्लम ये है कि मुझे सर क्लास में कॉलेज में
Net, you have to solve for the
एलएमएस
for
खोल
the
नहीं
time
रहा
being.
सर.
Net system you have to solve for the time being because you are out of the college. College can provide you cannot provide you net, not can provide.
और सर मैं अभी तक enroll नहीं हूँ.
You have to provide your net. You have to arrange your net. Your exam will be very
सतीश
contact very
आप
soon.
बोलो तो एक बार फिर से.
Your exam is coming, and class test is going on. Maybe the end semester will also go within a month.
सर बोल रहे हैं LMS ओपन नहीं हो रहा और ओपन भी हो रहा तो enroll नहीं हो पा रहे हैं हम लोग. तो जो
Then you have to find
इंटरनल
some
है तो
places where it is okay. Okay, let me finish. What is the steam pressure control? The pressure control system, sometimes called boiler master. How do you control the pressure? You know what is the design or desired pressure of steam in turbine as well as desired temperature. And you are supposed to control it. And this sometimes called boiler master. Just 1 second, please. The speed cutter control. It is sometimes called boiler master because possibly it is the heart of your propulsion system. How you can control the pressure. It maintains the steam pressure by adjusting fuel and combustion air flow to meet the desired pressure. To maintain the flow pressure, steam pressure, you have to maintain the generational amount of steam generated, and you can only control that by adjusting the fuel burning and adjusting the air coming in, because you are mostly use almost 80% to 90% air by water by recycling, so you have little control over it. But the fuel you are supplying again and again, that is the coal, and the air which is required to supply the oxygen for burning, you have to supply again and you have to make a continuous supply. So you are supposed to control these two parameters if you want to control the generation of steam in volume and in pressure. So what will you do? You have to depend on few sensors. One is steam pressure sensor, which is goes to the pulverized coal power drive and free draft fan drive, and steam flow sensor and airflow sensor, which is the trimming signal. These are the five sensors: steam, pulverized power, load draft, force draft, airflow, and steam flow. These are the five sensors you have to control. When the pressure drops, flows are increased, and a steam pressure sensor acts directly on the fuel flow. Steam pressure sensor will control the fuel flow, and airflow controls fuel and airflow, such as the pulverized coal power drives and forced draft fan to attend the result change, draft fan to affect the result change. How the air is coming? Through a fan. It is a that if you have to run the faster, slower, or medium size. Pulverized coal, you are supplying it. Coal should not be in the same size which you have taken from the mine. You have to break it by pulverization, which is called pulverization. You have to break it with certain size, and it is to be supplied through a conveyor itself. And you can control both of them, as well as the airflow, as well as the pulverized flow. And because both of this amount of fuel is coal presence is required by the required to control the power, and forced draft fan is required. The speed is required to control how much air it is delivering itself. A trimming signal on fuel flow and airflow sensor maintains the proper fuel air ratio. Means there is specific amount of air is required for a specific amount of flow. So you have to maintain it, and there will be another signal which is the output of both of them. At the output of both of them will give you whether this air fuel ratio is properly maintained. This is called trimming signal. Since it is often difficult to obtain accurate fuel flow, a steam flow sensor is sometimes substitute the fuel flow sensor. So it is difficult to give the supply perfectly or control the supply. You are going up the conveyor speed, reducing conveyor speed, make the Indian conveyor. It is comparatively difficult thing. So instead of it, a steam flow sensor is sometimes substitute the fuel flow sensor. About its 5s delay is allowed, 5-second delay is allowed when charging coal flow and air flow to ensure the prevention of a monetary rich mixture with high fuel ratio, and this assumes smoke-free conversions. So the fuel ratio is the right, you have the right ratio, the smoke will produce less and less harmful products will be created, because all will convert it to carbon dioxide and go. Carbon dioxide, less amount of carbon monoxide or so, and sulfur dioxide and so. They avoid any possible accident due to rapid pressure rise caused by the failure of any of the system. The safety valves are installed in strategic location. Now, that is the one most important part is the safety valve. To maintain the correct pressure, if everything goes well, no problem. But if somehow due to some malfunctioning of say fuel flow, so air flow, the pressure becomes, or you are supplying more air and fuel than is reserved. So there, because turbine is not required to be generated so much of the power, your pressure inside the system goes up. So you have to have the safety valve in the system in different places, which is supposed to be critical places, and where it will release some of the vapor to the atmosphere, so that the vapor content inside the system will be your vapor pressure inside the system will be your required vapor pressure itself. This is the system of systematic air pressure control system. What we have, this is the inlet. Your steam will come here. The seat is there. It is preventing the flow of, it is having sealing the matter and preventing the flow. And this is the outlet. So if this seat is properly fixed over it, it will prevent the steam from going out to the outlet. And this seat is being controlled by this spring and spring housing. This is the spring, and the spring adjuster is there. You have to move it. This handle you have to move to adjust the spring pressure to up to the desired limit before that, so that the steam vapor pressure inside the system will not go up. It will not increase up to a certain limit. But if it will increase the more than spring pressure, the spring portion will go up, release the outlet, and the additional steam will go out. And the pressure, when pressure will release, this spring will again push the seat inside the inlet cavity itself. So this is the total body, seat and disc here, and spring housing is the total housing of the spring itself, spring and pressure pressing handle by rotation. And with this adjuster, it will press the spring more or less. Higher with the pressing, the spring is more compressed. It requires more power effort to release it, and spring is less compressed. It will less able to release it. So you have to adjust it according to your requirement itself. Okay, this is the so much to for this thing for today.